everyone, and welcome back to another video. Now today again we want to look at the integration by partial fraction, which is the same thing that we looked at it on the previous video, but this is different problem. So as you can see on the board, x, all of the integral of x all over x minus 1, x minus 2 squared, changing x. So the first thing that you are supposed to know here is how you can break the denominator into partial. How can we compose the denominator here? So if you can see that is the linear factor, but this is also the linear factor doubled. So we have a over x minus 1, that is the integral changing x, plus b over x minus 2, the integral changing x, then plus c over x minus 2 squared. The integral then change in x. So the first thing is to understand that, for example, if you have 1 over, the integral of 1 over x minus 2 cubed, change in x, then for you to decompose this into partial fractions, you have a over x minus 2 plus b x minus 2 squared, take note on that, plus c, then x minus 2 cubed. So this is what you are supposed to apply there. So let's proceed. After decomposing it like that, then now you can fill in, you multiply both sides by the LCM, then you can now get A, B, C. So before we proceed here, if you're watching us for the first time, please subscribe to this channel so that the next time we produce a wonderful video, just like the one you want to watch, then YouTube will automatically notify you. So let's go back here. Let's now write without the signs, x over x minus 1, x minus 2 squared is equal to a over x minus 1 plus b x minus 2 plus c x minus 2 squared. So the first thing is to multiply both sides by the LCM, and our LCM is the denominator of this, x minus 1, x minus 2 squared. You multiply both sides by that, x minus 1, x minus 2 squared. So this one will go, as you can see, this one will go with that. We'll cancel that one out. So we remain with x is equal to, so x minus 1 goes here how many times? You can see it will cancel that one out, and we remain with x minus 2 squared. So we have a into x minus 2 squared plus x minus 2 will go this one, and we shall remain with x minus 2, multiply that. So we have b into x minus 1 and x minus 2. Then the last part of it will be c, x minus 2 squared will go x minus 1 time. So we have x minus 1. So that is the first procedure. So what you want to do, because we have the 3 unknown values in that one equation, so we're going to eliminate either A, B, and C. We're going to eliminate them in a way that we have the total product to be 0 so that we can get other unknown values. So let's start by putting, when I put x here to be 2, then this is going to be 0. Then that means that we have already eliminated either B or C or A. So let's say when x is equal to 2, so we are going to have, now when we put x to be 2, then it's going to eliminate A and B. So let's proceed. This is going to be 2 here, then A, 2 minus 2 squared plus B, 2 minus 1, then 2 minus 2 plus C, 2 minus 1. So as you can see, this is going to be 0, this is also going to be 0. So we have 2, A 0 plus B 0 plus C 1 multiplied by C. So we have eventually c is equal to 2. So again, when we put x is equal to 1, as you can see, so it's also going to eliminate that. So again, let's put when x is equal to 1. Then substitute back. So we have 1 is equal to a 1 minus 2 squared plus b 1 minus 1, then 1 minus 2 plus c into 1 minus 1. So we have 1 is equal to, this is a, negative 1 squared, plus this is going to be 0 because 1 minus 1 is 0. So we have b 0, plus this is also 0. So 1 is equal to a, and 1 squared is 1. Negative squared is 1, so we have a is equal to 1. So let's go to this part and find c, and find b, I mean. So again, when we put x to be 3, so what do we have? So we're going to have 3 is equal to a into 3 minus 2 squared plus b 3 minus 1 into 3 minus 2, then plus c into 3 minus 1. So we have 3, this is 1, which is 3 minus 2 is 1, 1 squared is 1. So we have just a plus, this is 2, 3 minus 1 is 2, so we have b into 2, that is 1, plus c into 2. So we have here 3a plus 2b plus 2c. But we already found a and c. So c is 2 and a is 1. So we have 3 is equal to 1 plus 2b that we want plus 2 multiplied by c. And our c is 2. So that is 3, 1 plus 2b plus 4. Plus 4. So 1 plus 4 is 5. So we have 3 is equal to 5 plus 2b. So when we take the other side 5, then we have 3 minus 4. Let's get the value of b here. So this 3, 1 plus 2b plus 4. When we collect the like terms, 1 plus 4, we get 5 plus 2b. So we have 2b is equal to negative 2. So b is equal to negative 1. So when you substitute back, so we have the integral of a, and our a was 1 over x minus 1, change in x, plus b, but our b is negative 1. So we have negative the integral of 1 over x minus 2, change in x, then our c is 2. Our c is 2, so that one we have plus 2 over the integral over x minus 2 squared change of x. So we know very well that the integral of 1 over x minus 2 is the ln of this. Then integral of 1 over x minus 2 is also ln of x minus 2. But what about this part here? So this is the part that we want to look at it aside here. So let's get the integral. Let's see the integral of 2 over x minus 2 squared, change in x. So the first thing is to take this to the other side. So we have 2, the integral of 1 over x minus 2 squared, change in x. So here, I want to use substitution. Use substitution to get the integral of that. So let u to be x minus 2, then du to be dx, dx to be du. So we have the integral of 1 over u. Let's substitute back. So we have the integral of 1 over u squared du. So integration of that. So we have u negative 2, you add 1, then over the total sum of the indices, which is negative 1. So we have eventually negative u negative 1. So when you write it back again, so we have negative 1 over u. And remember, u is x minus 2. So that becomes negative 1 over x minus 2. But remember, when I bring 2 again here, so eventually we have negative 2 over x minus 2. So that's the integral when I use the u substitution of 2 minus, over x minus 2 squared. So this is now, we are going to bring it back here. So let's finalize it here. So the integral of 1 over x is ln of x minus 1 minus ln of x minus 2 plus, and we have a minus. Now we have minus 2 over x minus 2. Remember, if you're getting the integration, then you need to add c. But now I can use this as a single log. I can put it as a single log. You know that, let's look at remind ourselves something here, that if you have the ln of x minus ln of y, then you can put this one as a single log as ln of x over y. So that's what I want to apply there. So finally, we have the ln of x minus 1 over x minus 2 minus 2 over x minus 2 plus c. So you guys, that is our final answer to this problem. So if you've learned something, please give this video a thumbs up. Bye bye, and see you in the next video.